Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain about what is the relation between resistance of a conductor and temperature. Is nothing but simply what is the relation between resistance and temperature. Is nothing but how resistance is depend upon the temperature factor. Resistance of a material or conductor or conducting material. Resistance of a conducting material varies with temperature. It is a very important point. Resistance of a conducting material varies with the temperature. R of T is equals to R naught into 1 plus alpha delta T or T. That formula is also very important. Okay, so this one is here. R is the resistance of conducting material at the T temperature. R is the resistance of a material, okay, initially, means in the starting of the experiment, means before connected to the circuit, means this is called internal resistance. So 1 plus alpha is the coefficient of linear expansion, because of, we know that according to the thermal properties of solids, liquids and gases. Okay, in the solids, already we discussed in that in IIT mode in the lower standard level. So, if we can take the any solid substances, if we can heat it that one, it will be expanded in the three ways. Means length, area and volume. Means length, breadth, height, mode. So, length means only we can set the where is the length. Means length is either okay. If when you can heat the any solid body, if its length is increases, that is called linear expansion. And okay, in case of the two-dimensional bodies, we both, what is that one? Okay, in case of a only wire, we can say that okay, simple. Certain large thickness of the wire, we can say that when we are heated, what will happen? Okay, the length will be increases. That is, you know that. But in case of some other materials, we are observing that okay, areal expansion and cubical expansion. Areal expansion means when you are consider the length and breadth. So length, breadth, height of that one we consider which one cubical expansion. That's why when you can heat the any solid of substances, it will be expanded in the three ways: linear, areal and cubical expansion. So linear expansion we are called alpha, cubical is beta, areal is beta, cubical is nothing but volume expansion, we can say, given by symbol of gamma. Anyone here alpha is the linear expansion. Why? Because of we can take the thick copper materials or material. That's why the thick copper materials area of the cross section is less. That's why we are not considered. Only we consider that the length of the wire increases more. Based on that one, but generally how it will break means we know that alpha coefficient of linear expansion is equals to RT minus R naught upon R naught into delta T. So from that one, that is the exact formula of coefficient linear expansion. Okay, from that one we can write this one. Okay. So resistance of a conducting material varies with temperature. That is, you can find this one. If resistance is increases, temperature is also increases, but not that one, correct? Exactly. If temperature is increases, resistance is also increases, means directly proportional. So the temperature of a conducting material, the temperature of a material is directly proportional to the distance of the wire. How we can say that? Means I said that simply. For example, one truck and one car, we can say that the truck has huge mass, car is the lesser mass when compared to the truck. We know that a truck is initially in the rest position. Truck we can see as the ions and atoms present inside the conductor. Here, car is in the motion according to our concept. It is the free electrons move from one place to another place within the conductor. So we know that initially car mass is 800 kgs and it will be moved with simple I say that 10 kilometers per hour. When a car of mass is 800 kgs and move with 10 kilometers per hour, it will be collision the which one truck. At that time, the car will be has the any greater damage? No, only little bit damage only is there. Maybe bumper or some scratches will be there. Is it correct or not? So means why? Because of means that due to the lower velocity of the due to the lower kinetic energy, simply due to the lower kinetic energy of the car. So after collision with the truck, what will be happen? It loses the lesser energy. It's nothing but again the car will be returned to come back and move into forward way. But the same car, we can say that the car is moving 100 kilometers per hour and collision with the which one same truck, then what will be happen? The car will be greater damage. Further, the car does not move into the forward direction. Is it correct? Why? Because of means here, what is the changes? Only velocity. Mass of the car is constant, but velocity is different. If velocity is changes, kinetic energy is also changes. That more we discussing here. So, according to the kinetic theory of matter, we know that if temperature is increases, kinetic energy of molecules or particles is also increases. I clearly explained in the fifth chapter. If the temperature is increases, kinetic energy of the molecules or particles is also increases. If the temperature of the electrons are increases, how the temperature is increases? When we know that when the electrons are collision with the other ions and atoms initially, they loses some energy. At that time, during the collision, they produce little bit of energy or not. So that is depend upon the applied voltage. If we can give the more potential difference, electrons are getting the more energy and collision with the other one, and they produce the means it is very less also, but in the microscopic way, a huge heat energy. That heat energy will be absorbed by the surrounding electrons, and they acquire the more energy. Why? Because of already the electrons will be having some energy with the from other, and also during the collision of the other electrons, there is some heat energy. That heat energy will be absorbed. That's why, so the electrons kinetic energy will be increases. How we can say that temperature is increases? By absorbing the heat energy, we know that if your body is absorb the heat energy, its temperature is increases. That's why if the temperature of the electrons are increases, its kinetic energy is increases. That's why electron will be collision number of times with the ions and the atoms, because of they move fastly. Due to the fast, what will happen within the fraction of second? It will be collision number of times with the ions and atoms present inside the conductor. That's why they loses huge energy. Is nothing but more opposite force is acting. We know that according to the Newton's third law of motion, to every action there is equal and opposite reaction. If electron will be move with higher velocity and collision with the ions and atoms, then they will be also apply the same amount of force. That's why what will be happen? So it will be collision with how much one? They are also apply the same force. That's why it is collision with less. It is also apply the less. Means by increasing the kinetic energy. Means when increasing temperature, by increasing the temperature of the electron, their kinetic energy increases. That's why the collision number of times with the ions and atoms, then more opposite force is acting on the electron. That is the reason. So that's why more opposite force will be acting on the electron when temperature is increases. That's why if temperature is increases, resistance of the material is also increases. That is one. Once again, listen very carefully. Resistance of a conducting material is varies with the temperature. Formula R of T equals to R naught into 1 plus alpha into delta T. Here alpha is the coefficient of linear expansion. That is you can take it from like that one. So if the temperature of a material is increases, resistance of the material is also increases. Reason. Okay. According to kinetic theory of matter, temperature is increases, kinetic energy of molecules or particles is also increases. Like that mode, if the temperature is increases in the conductor, the kinetic energy of the electrons is increases. That's why the electrons will be collision number, means number of collisions also increases with the ions and atoms and losses the more energy. It's nothing but more opposite force is acting. That's why if the temperature is increases, resistance is also increases. Means okay, resistance of a conducting material is directly proportional to which one? Temperature. This type of, this is the matter you can write during the examination when they are asking this concept. Now I will give some more other extra information about this. If temperature increases, the resistance of metals are simply the resistance of linear conductors, means metals and alloys simply. Metals and alloys. If temperature increases, the resistance of linear conductors also increases. If temperature increases, the resistance of semiconductors such as carbon, silicon, germanium, etc. are decreases. Isn't it? Is decreasing. So, if temperature is increases, the resistance of linear conductors is nothing but such as metals and alloys. Okay, resistance is increases. But if temperature is increases, the resistance of semiconductors such as like carbon, silicon, germanium, aluminum. So in this one, the resistance will be decreases. That's one only when the temperature is increases, the semiconductors resistance will be decreases and they will be allow the current very easily. This one is it. Next we will discuss the conductancy. It is given by the symbol of G. the reciprocal of resistance, is called conductancy. Resistance is nothing but some opposite force is acting. That's why electrons does not carry the current easily. But conductancy means allow the current easily. So the reciprocal of resistance is called conductancy. G is equals to 1 upon R. Unit. So simply 1 upon ohm means ohm inverse. Okay. Or it is simply we are called ohm. Okay. Ohm inverse means OHM. Ohm is there. Ohm inverse we can means inverse means reverse. MHO more we can write. R. Okay. Simon. Because of George Simon Ohm. That's why for the hand of that scientist. Okay. Ohm. Okay. The units of conductancy is ohm inverse or mho or Simon. Next topic is specific resistance or resistivity, rho. The resistance of a conductor of unit length and of unit area of cross section is called specific resistance or what is that one? Resistivity. It was given by the symbol of rho. So formula rho is equals to, how we can write the formula means, already we know that according to the resistance concept, R is directly proportional to the L and R is inversely proportional to the A, so that R is directly proportional to L upon A based on that mode. That's why here we know that simply we can write that. We know that R is directly proportional to L, R is inversely proportional to A. Then what we can write? R is directly proportional to L upon A. Then R is equals to rho into L upon A. Means if we are eliminated this symbol and introduce the equality symbol between these two physical quantities of the left hand and right hand side, we must be use one proportionality constant. Here rho is the proportionality constant. It is called specific resistance of a conductor or resistivity. That is one is there. Now from this one, rho is equals to A transfer to this side, R A upon L. So this is the formula of which one? Specific resistance or resistivity. The resistance of a conductor of unit length and unit area of cross section, that is called, means length is one particular value, area is also one particular value. That of, okay, means 1 meter, for example, 1 meter length and 1 meter area of the cross section. We can take in that. What is the resistance of that conductor? That is simply we are called as, okay, means here length is does not change and area is also does not change. Length and area is unit, means okay, values. Length is not change, area means both are constant, that is the meaning at that time. So the conducting wire is having how much resistance, that is called specific resistance or resistivity. So now here this is the formula to find that one. Rho is equals to RA upon L. Unit. So SI unit or unit of specific resistance or resistivity. RA upon L. R means we know that ohm, area means meter square, upon L means meter. Meter get cancelled, that is equals to what you can write, ohm meter. That's why what is the SI unit of specific resistance means ohm meter is the SI unit of specific resistance. Simple. Rho is independent, means not dependent, independent on the L and A, means listen very carefully. So specific resistance or resistivity of a material is not dependent on the length and area of cross section of a material, of a conductor. Why? Because of, I said very clearly, resistance, specific resistance means you must be taken unit length and unit area of the cross section, means it is not variable factors, these are the constant values. That's why for a constant length and area of the cross section, what is the resistance of that wire? That is called specific resistance. Due to that one, L and A are constant. That's why what you can say is that rho is not independent on the L and A. For example, if length is increases to 1 meter, then area is also increased to same value. At that time, what will happen? If length is increased, flow of current is increased. If area is if length is increased, flow of current is decreased. If area is increased, flow of current is increased. That's why by increasing the length, current will be decreased. By increasing the length, flow of current is decreased. First step. By increasing the area of cross section, flow of current is increased. That's why by increasing the length, current is decreased. By increasing the area, current is increased. Finally, both are same. Then finally, what is the resistance? Does not change. That's why that says that rho is independent on the L and A of unit length and unit area. But rho is depends on the nature of the material, temperature and impurities, by adding the impurities. So listen very carefully. Specific resistance or resistivity is not dependent on the length and area of the cross section of a conductor. But specific resistance is dependent on the nature of the material, temperature and impurities. Just two important points. Specific resistance or resistivity is less for metals and alloys. Hence, metals and alloys are called linear conductors and they act as a good conductor of electricity. The resistivity of metals, okay, is nearly in order. Okay, means the common order is 10 power minus 8 ohm meter. It is very less. The resistivity of alloys is 10 power minus 6 ohm meter. That's why due to the lower resistance, what will be happen? Means due to the lower resistance, they act as a good conductors. Rho is more for insulators. Rho is more for insulators. Hence, they act as bad conductors. Means rho is more for insulators in certain materials. That's why they act as bad conductors. Means, for example, in rho value for insulators in order 10 power 3 ohm meter to 10 power 22 ohm meter. 10 power 3 is nearly for wood. Okay. So A is 10 power 6, 10 power 22 is enough. Okay, one type of gas is there. So anyway, so means here rho is more for insulators, hence they act as bad conductors. And rho value for insulators in the order like this one, 10 power 3 ohm meter to 10 power 22 ohm meters. That's why due to the high resistivity or specific resistance, what will happen? They do not allow the current passing through them. Next one is conductivity. Sigma. This is called sigma. Okay. Resistance denoted by the symbol of R. Conductance denoted by the symbol of G. Specific resistance or resistivity denoted by the symbol of rho. And conductivity means reciprocal of resistivity. Listen very carefully. The reciprocal of resistance is called conductance. The reciprocal of resistivity or specific resistance is called conductivity. The reciprocal of resistivity is called conductivity. So listen very carefully. The reciprocal of resistivity is called conductivity. Sigma is equals to 1 upon rho, that is equals to 1 upon RA. This is the formula. So rho is the resistivity. Reciprocal of resistivity is called conductivity. SI unit is Simon meter power minus 1. Is nothing but simply Sm power minus 1. Why? Because of, we know that 1 by R we call as means 1 upon R. What is that one? Reciprocal of resistance is called conductance. What is the unit of conductance? Simon. That's why 1 upon R, this is you can write 1 by R into 1 upon A, that is equals to 1 upon R we can write as a Simon into 1 upon area means meter square. Okay. Sorry, L upon A. That's why what we can write here, okay, 1 upon R into L upon A we can write. 1 upon R is Simon into L upon A. L is the meter, area is meter square. 1 meter get cancelled. Then what we can write? Simon into meter power minus 1. It brings to the numerator side. That's why the SI unit of conductivity sigma is called Simon meter power minus 1 or SI power minus 1. These topics are not there, but it is useful for bit purpose or 1 mark or for complete examination purpose. That's why I will explain to you. Next one is superconductors. Superconductors. The materials whose are allow the current continuously. After remove the potential difference across it. So listen very carefully. The materials whose are allow the current continuously after removing the potential difference across it, that materials we are called superconductors. Listen very carefully. What we know that at the two ends of the conductor we connected to the, okay, means simply P, Q, like this one. P and Q are the two ends of the conductor. Across this conductor connected to the battery. Then what will happen? Means this battery is create the potential difference across the conductor. That's why electrons will be drifted, move from one place to another place. That is P to Q or Q to P anyway. Okay, from inside out. So P to Q we can say that. Now in this one, current is flowing through the material. But if we remove the battery, what we know that current does not flow through the conductor. Is it correct or not? But here, what will happen? Okay, so in some of the materials at the critical temperature, listen very carefully. The sum of the materials at the critical temperature, what will happen? After removing the battery, they continuously allow the current. Listen very carefully. Sum of the materials at the critical temperature, after removing the potential difference across the it, they continuously allow the current. That materials are called superconductors. Based on that one, you can write the definition again. I will rewrite the definition. So listen very carefully. By connecting a battery at the two ends of the conductor, so current is flowing through the conductor. Now we can remove the battery. We know that no current is flows through the circuit. But so in some of the conductors at particular temperature, we are observing that after first we connected to the battery, current is flowing in the conductor. Now we can remove the battery also. The current is continuously flowing through the wires up to some of the years. So the conductors we are called superconductors, but still the scientists will be not achieve that one, but they find particular temperature only. Listen very carefully. At critical temperature, some of the materials at critical temperature, some of the materials the amount of current passing through the at critical temperature, the amount of current passing through the materials or conductors after removing of potential difference, across it, that materials we are called superconductors. That is the exact definition. At critical temperature, the amount of current passing through the materials continuously after removing of potential difference also, that materials we are called superconductors. In 1911, Ohms find in the mercury its critical temperature is 4.2 Kelvin. Means so in the 1911 the Ohms scientist will be find out in his experiment about the mercury. In case of mercury material or mercury substances, if the mercury temperature we can decrease up to the which one 4.2 Kelvin temperature. At that time, mercury acts as a superconductor. Listen very carefully. Means the mercury substance at the 4.2 Kelvin. 4.2 Kelvin is called critical temperature, like critical angle in the chapter of refraction of light at plane surface, like that one. So at the critical temperature of mercury, what is that one? 4.2. So below the 4.2 Kelvin critical temperature, the mercury, what will be happen? It is allow the current continuously after removing the battery at the two ends of the circuit. That is the meaning of that. Like the same way, so the scientists will be still, they conduct so many experiments on the different materials of the conductor, even still now also. But it is still no one cannot be achieve the superconductivity. If you can once achieve the superconductivity material, what will happen? So the battery, without using the battery also, the current will be flowing through the wires, means the bulb and everything, it will be glow without using the electricity. That is the meaning of that. Listen very carefully. So in 1911 year, Ohms will be in his experiment was find out that the mercury material will be at 4.2 Kelvin temperature. It will be so acts as a superconductor. What is a superconductor? At one critical temperature, the amount of current passing through the conducting wire continuously after removing the potential difference at the two ends of the conductor also, the current is flowing through that one months and years also continuously. That is one. That is the brief idea about the which one superconductors. It is important for 1 mark only. Thank you.